In this lesson, we'll talk about number structure and place value. All our numbers are built out of digits. What are digits? Well, those are numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 digits, and those are all the signs that we need to represent any number that we wish. For example, number 10 is built out of 2 digits. That's a 2-digit number. Notice that 1 on the second place value starting from the right to the left doesn't really mean 1. It actually means 10, 110. So the value of a number that we create depends not only on the digits that we use, but also on the position of those digits. Let's create a 3-digit number. This time we used 3 digits, 1, 2, and 5. So that's why such a number is called 3-digit number. And it means 125. Again, notice that the digit 5 represents ones. We have just 5 units. The next digit to the left represents 10 times larger values. So it's not just 2, but it's 2 tenths. And the following digit 1 represents 100. So remember, in the number 10, 1 represented 110. In number 125, the same digit 1 represents 100. So the position of a digit in a number is critical for finding the value of the number. For example, if we rearrange digits 2 and 5, we create a different number. It is 152. This time we have 5 tenths and 2 units. Our number system is actually called base 10 system. What does it mean? That really means that each place to the left has 10 times larger value than the previous place. So 5 on the second place value represents 50, which is 10 times larger than just 5 ones. And 1 on the third place value represents 100, which is 10 times larger than 110. And obviously we could add some digits in front, making the number even larger. Take a closer look at our number structure. Let's create a number with more digits. For example, 6-digit number. As soon as we have more than 3 digits at a time, it's really hard to handle such a number, as our perception is usually okay to focus on 3 items at a time, but more than that, 4 or 5 or 6 or even more, well, that's a little bit too hard. So what we do for large numbers, we are grouping every 3 digits starting from the right towards the left. We are grouping them by leaving an extra space between each triple, so it will be easier to read large numbers. In this example, we have 2 groups of 3 digits in each. And when we try to rate this number, we're going to focus at 3 digits at a time. The first group of 3 digits will be called units. And within this triple, we recognize the following place values. Starting from the right towards the left, we have ones, tens, and hundreds. So this number represents 169. 100, 6 tens, 9 ones. But if the number is larger, like in our case we have another triple, well, to recognize that we refer to the second triple, we need to name the second triple differently. It won't be units. We will talk about thousands. Within those thousands, though, we still can recognize the 3 basic place values, ones, tens, and hundreds. So that's how we structure our numbers. Every 3 digits from the right towards the left, a space. Another 3 digits and a space. Possibly we may have more digits to the left, so again we group them in threes. If there is no full 3 digits, for example, it's just 1 digit here, that will be the start of the next group as well. Sometimes, instead of spaces, we use commas to separate each triple of digits. So how do we rate this number? Well, we rate the regular way, like we will just have 705, and then we say 1000, which indicates that we are talking about the second group of digits. After that, we use comma, and then we read 169. So altogether we have 705,000, 169. Notice two things. First of all, we use the comma to separate the consecutive triples, and if a two-digit number is written using two words, we place a hyphen between those words. For example, this 69. So if we will have 21 or 87, we'll use hyphen. Let's look a bit closer at reading our numbers. As we mentioned before, we group numbers in triples. On the previous slide, we've been talking about the triple of units and the triple of thousands. But obviously we can create larger numbers, so we should know the names of a few following triples. For example, in this number, as before, the last group consists of units, and within this triple, we are talking about ones, tens, and hundreds. The next triple is the triple of thousands. Again, within thousands, we are talking about ones, tens, and hundreds. So the digit 9 represents hundred thousands. The digit 0 represents 10,000s. And digit 4 represents just thousands. The following triple is called millions. So we have units, thousands, millions. And again, within millions, we can recognize ones, tens, and hundreds. And the next triple is called billions. And again, in the group of billions, we can distinguish ones, tens, and hundreds. In this particular example, this triple is not fulfilled because the number starts from 10 billions. It's not larger than that. So that's okay. In the last triple to the left, we may have 3 digits, 2 digits, or even 1 digit. If we wonder what would be the name of the following triple, well, that will be trillions. But so far, it's okay if we know our numbers up to billions. That's so much anyway. As I mentioned before, instead of extra spaces between each group of 3, we can use commas. In various textbooks, you can see numbers written with spaces or numbers written with commas. That really means the same. Okay, let's read this number. How do we read it? We'll read the regular way each triple, then we name the triple, and then we use comma to go to the next triple, and the algorithm starts all over again. So this number will be read 21,780,904,169. We don't need to say units because it's kind of assumed. The last triple is about units. Well, let's write this number. 21 billion, 780 million, 904,000, 169. Notice the hyphen in each two-digit number that consists of two words, like 21. 80 is represented by one word, so we don't need any hyphen. 4 is just one word, but 69, again, we have a hyphen. Also, we use commas between each group of 3 digits. Observe that when we rate the number, we use words like billion, million, thousand. We don't use s at the end of those names. So that's something to remember. When we talk about general place value, we are naming them as billions, millions, thousands with s. But when we talk about specific number, 21 billion, 780 million, we don't use s. Okay, now let's look at writing numbers. Let's say someone writes 1,205,074,520. We would like to recover this number, write it in standard form. So, keeping in mind that the number is grouped in triples, let's start from the right side and just underline the place values that we are going to fill. So that will be the group of units, group of thousands, group of millions, and finally part of the group of billions. We have 1 billion. Well, so 1 goes on the billion place value. 205 of millions. That's a group of millions, so we write 205. Then 74,000, that's the group of thousands, so we write 74. 74 is just 7 tens and 4 ones in the thousands group. Therefore, we don't have 100 thousands at all, so we are going to fill in this empty spot by 0. And finally, 520. So 520 over here. We have 1,205,074,520. Notice one more thing. Before the last triple, we do not use AND. Sometimes people like to put AND there, but that's different meaning. AND will actually be reserved for a decimal dot, which we'll study a little bit later. So when reading or writing whole numbers, we don't use the word AND. Let's look at another example. 301,040,600,000. As before, let's prepare our empty place values, so it will be easier for us to fill up. And this time we can start from the end. We have 600, so in units group, we'll write just 600. Let's go to the next group, which is called thousands. But we don't have any thousands, we have 40 million. Okay, then we need to skip to the following group. That's the millions group. And there's 40 of them. Well, let's write 40. There is no 100 millions at all. So what we need to do here? Yes, fill up by 0. And what to do with those places? There was no group of thousands at all. No thousands. That means that the entire group will be filled by zeros. Finally, the largest group, the billions group, contains 301. So let's write 301. And then we can place commas between those groups if we wish to. So that's 301 billion, 40 million, 600. We don't need to say 0,000. We just skip this 0 group and read 600. Another thing that we'll look at is expanded form of a number. Here we have an example of a number. As you see, we have 3 groups indicated: units, thousands, and millions. The expanded form of a number shows us the number as a sum of each non-zero digit with its place value. So how does it go? Well, this number contains 1 million, so we have 1 on the millions place value, and also 200,000, so we have 2 on the 100,000s place value, and then 4,000, so we have 4 on the thousands place value, and 80, 8 on the tens place value, and finally 5 ones. So if we rewrite this number as a sum of those values, that's what the expanded form is. Okay, let's write it down. 1 million plus 200,000 plus 4,000 plus 8 tens plus 5 ones. So we can write our number as 1 times a million. A million means 1 with 6 zeros, because then this 1 is on the millions place value. And then we add 2 at the 100,000s place value, so we write 2 as a digit and the place value hidden under multiplication by 100,000. Next we add 4 as a digit, 4,000, so 4 times the place value, 1,000. Next plus 8 times the value of this place, which is 10, and finally plus 5 times the value of this place, which is just 1. So in expanded form of a number, we list all non-zero digits of the number, multiplied by their corresponding place values, and then add them up. So 1 was on the millions place value, 2 was on 100,000 place value, 4 on the thousands place value, 8 on the tens, and 5 on the ones place value. Notice that we've been using multiplication between the digit and the value of the place. Some of you are used to seeing multiplication as a cross like this, but we can also use a dot for multiplication, and actually in preparation for algebra, I would encourage you to use a dot at the middle of the line, because this cross can be easily confused with a variable x that some people write like this, but other people just write like this. As you see, it's nearly the same as this cross. So in order not to get confused later on, we prefer to indicate multiplication by writing a dot at the middle of the line rather than a cross. But these two signs really mean the same. Let's practice recognizing place value. In the first exercise, we want to identify the place value of digit 5 in each number. So, what is this place value? Well, the 5 is in the last group, which is group of units, and within units we have ones, tens, hundreds. So 5 is in a hundreds place value. So we write hundreds. What about that one? Well, this time we are referring to the second group. This is the group of thousands. And again, within thousands we have ones, tens, hundreds. So 5 is in 10 thousands place value. We write 10 thousands. In the second exercise, we are asked to determine the number using the following information. The number contains 6 tens, 0 hundreds, 3 ten thousands, 8 ones, and 4 thousands. What is the highest place value out of all of them? Well, 10 thousands. So let's prepare our empty spots by drawing, just underlining like that. And it has to go until 10 thousands. So triple of units and then thousands and 10 thousands. Now we can put our digits in appropriate spots. 6 tens. Well, it goes where the tens are, so the second digit, that's 6. 0 hundreds. Hundreds are in the third place from the right, so we have 0 here. 3 ten thousands. That's a thousands group. Ones, tens. That's a 10,000 column. So we have 3 there. 8 ones. That's an easy one, the last digit. And 4 thousands. That's a thousand place value. Place it 4. So our number is 34,068. And I hope that's good enough. Let's check your textbook and practice more.